Hi. Okay, so let me show you our new hybrid analysis system with GenFEA Web and what that means and how it works. So to set this up, I'm going to just bring in a couple of sections from my material database. I've sped this up a bit so you don't have to watch me doing it in slow motion. But essentially, I'm just bringing in a couple of universal columns, universal beams, some cold form lip channels, and some circular hollow sections for my profiles. And now I've activated the portal wizard, and I'm just populating some values there to set up my portal frame. And there's a bunch of options that you'll see there. Pretty much what you'd expect to see in a decent portal frame generator. So now I'm assigning those sections, and once that's done, I'm going to inspect the model. We can see it looks pretty good. All of those members generated, and all of the analytical conditions applied to it, things like supports, end releases, and so on. And we can, of course, access that portal. It's like a parametric block, so you can access it and make adjustments to it. And when you're ready, you can explode it. And you'll notice we're currently dealing with continuous elements. So I'm going to hit the discretize button there, and I'm going to uncheck bracing so that it splits those members at intersections apart from the wind bracing elements. And then I'm going to optimize those elements, and you'll see now we've got our discretized model generated from the web interface, which is pretty cool. And it's sorted all of the nodes for us by coordinates, and we can see it's already got the support conditions assigned to them as well by those degrees of freedom boxes being checked. And as far as load cases and load combinations go, we've only got a single load case by default, a dead load. I haven't added live loads and wind loads on this one yet, but we can set those up and go into quite a bit of detail should we need to. I'm not going to do it for this exercise, but we've got the options to do that. And of course, we can set up the load combinations based on the load cases that we've got. Currently, we've only got one, so we'll only have a load factor applied to the dead load case. Now, this is where it gets interesting. We've got this new analysis link button, and what this does is it provides a unique session URL. So we can copy that URL, and we can then launch our GenFEAx engine, which is a new desktop app we've created around the engine called GenFEA Analysis Link. It connects to the session that is currently running, and of course you require a license for this, but I've already accessed my license, so it shows valid and active there. And then we can hit the run and upload button, and what this does is it runs through all the load cases and combinations. It uploads it back to the GenFEA Web model environment, and all we do here is we say refresh and import results, and that'll bring the results directly into GenFEA Web again. So once we've got the results in there, it creates a snapshot, which you'll see there at the top. And of course, now we can start visualizing results. And we've built in a bunch of cool tools here. So we can select various design groups that we want to see, but we can actually combine them. So you'll see those checkboxes there, and we can select which load case or combination we want to view. And of course, we've got outputs for deflections, forces, and moments. And of course, just like I've shown in the other videos, we can select members here and plot the outputs of those elements directly in the graphical interface, or we can project that into the inspector on the right hand side. You can see those purlin moments are not transferring there because they're torsion pinned end members, by the way. But here you can see we're now selecting a chain of rafter elements to display that in the inspector. Hope you found that useful. More to follow. Thanks. Bye.